For this next section on variables under higher order roots, we're really going to need to remember how to do division with remainders. So it's all going to be very low division, easy division, but we're going to need to say that the remainder stays behind and the whole number comes outside. So here's what I mean by that. When I see the third root of x to the 10th, same way we did with square roots when we divide everything by 2, we're going to divide this power by the root number. So it's going to become x to the 10 thirds. What we're really doing is doing 10 divided by 3. If you think back to your elementary school long division days, what ends up happening is 3 goes into 10 3 times. 3 times 3 is 9. When I subtract 10 minus 9, I get 1. So I would call this 3 remainder 1. You definitely don't need to do out that division. You can just put it in your calculator as 10 divided by 3, and it'll show as 3.33. But essentially you need to know, well, if it goes in 3 times, that means I'm subtracting 9 from this number. I have 1 left over. So we're going to see it a few times with different examples, but basically, if you can keep this idea in your head as you use more modern tools to do it, this should tell you that I get x to the third that comes out evenly, because 9 is the largest multiple of 3 that goes in. I'm then left still with the third root of x to the first that remained. If I use the same idea when I'm doing the fourth root of x to the 10th, it becomes x to the 10th power divided by fourth root. If I think about the powers of 4, 4, 8, 12, 16, 20. 8 is the one before I get to 10. So I can say that this is going to be x to the 8 fourths. If I take 10 minus 8, I have left over x to the 2 fourths. This divides evenly and gives me an x squared outside. This is my remainder of 2 that stays under that fourth root. So it becomes x squared, the fourth root of x squared. Here when I do 10 over 6, 6 can only go in one time. So I get x to the 6 over 6, and then the remainder is 4 over 6. The one that goes in evenly goes outside the root just as itself. 6 divided by 6 gives me x to the first. The one that is remaining goes under that same root number, 6th root, as the power on top, x to the 4th. When we look at number 13, it has a number as well. So the first thing I want to do is take 27, ask my calculator, what's 27 to the 1/3 power? It'll tell me 3. So the whole number 3 is definitely outside the root. I then need to consider x to the 32 over 3. If I put this in my calculator, 32 divided by 3 would give me 10.67. That 10 tells me that I can take away 3 times 10 or 30. X to the 33rds, and it'll leave behind x to the 2/3. So this 3 is on the outside. 30 divided by 3 gives me x to the 10th that comes outside. And what's left over is still under the third root, x to the 2nd. For number 4, 16 to the power of 1/4. My calculator tells me is 2. X to the 30 divided by 4. I see the largest power, or the largest multiple of 4 that can go in is 28. That leaves me with 2 more. So this whole number 2 is outside. 28 fourths is really x to the 7th. And then left behind under the 4th root is this x to the 2nd. Final problem here, number 15. I have 2 variables. I don't have any numbers. So I can jump right to the variables. X to the 10 divided by 5 and y to the 17 divided by 5. Here, when I do 10 divided by 5, it divides evenly. I'm not going to have any remainder. So this is just going to become x to the second all on the outside. For this y, the largest multiple of 5 that goes in here is y to the 15th. That's going to leave me still 2 more y's to get to 17. This y to the 15th over 5 just gives me y to the 3rd. This y to the 2nd over 5 stays under the 5th root as y to the 2nd. When I put these two together, I get x squared, y to the 3rd, the 5th root of y to the 2nd.